So we've already learned 4 ways to prove that two triangles are congruent to each other. We've learned, and you don't need to write these down, but I'm just going to review. Side, side, side. Side, angle, side. Angle, side, angle. And angle, angle, side. And today we're going to learn the last theorem, or the last postulate, that we can use to prove that two triangles are congruent to each other. Now this next theorem that we're going to learn is actually specific to right triangles. Okay, so go ahead and take out your notebook and title it Hypotenuse leg congruence theorem, or HL for short. Now here are the words explaining what this all means. If the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of a second right triangle, then the two triangles are congruent to each other. So let's do an example. We have two triangles that are right triangles. Triangle, of course, ABC, and triangle DEF. And they are right triangles. So let's just go ahead and write that down. Triangle ABC and triangle DEF are right triangles. And since we know that they are right triangles, we can now see if we can use the HL, or the hypotenuse leg theorem. Now just a reminder, remember the hypotenuse is the longest side of a right triangle, or the longest side of a triangle, and the legs are the other two sides of a right triangle. They're the two sides of the triangle that make up the right angle. And in this diagram, we're told that BC is congruent to EF, and AC is congruent to DF. So now we have enough information to use the hypotenuse leg congruence theorem to prove that these two triangles are congruent to each other. As you can see, we have a hypotenuse. The hypotenuses are congruent to each other. The two legs are congruent to each other, and the two triangles are right triangles. So by HL, we can prove that these two triangles are congruent. So let's write this down. AC is congruent to DF, and BC is congruent to EF, and we know that AC and DF are the hypotenuse, and BC and EF are the other parts of the triangle, so the legs. And so by HL, we can prove that triangle ABC and triangle DEF are congruent. Alright, so an example. I have a rectangle here that I'm going to draw. And it's rectangle J, K, H, G. And there's a line that divides these two triangles in half. And because this is a rectangle, we know that all our corners are right angles. And we're told that JG and KH are congruent. Are these triangles congruent? Well, we can see from the diagram here that triangle JGH and triangle JKH are both right triangles. I'm going to go ahead and write down this fact. So triangle JGH and triangle HKJ are right triangles. Now, if they're right triangles, again, we're going to see if we can use the hypotenuse leg congruence theorem. So let's look here. Oh, we see that JH is the hypotenuse for both triangles. And since JH is equal or congruent to JH, we can go ahead and prove that the hypotenuse of these two triangles are also congruent. And this is by the reflexive property. So our hypotenuse here is side JH, and we know that side JH is congruent to itself, and so we know so far that the hypotenuse of both triangles are congruent. And again, this is by reflexive property. We also see here that our two legs are congruent. So leg JG is congruent to leg KH. And this is because it's told to us. And so yes, we do have enough information to prove that these two triangles are congruent because first of all, they're right triangles. Second of all, their hypotenuses are congruent to each other. And third of all, one of their legs are congruent to each other. So, by the HL theorem, triangle JGH is congruent to triangle HKJ.